Silence. 45 seconds of pure silence. Only the faint hum of deep space ambience, a low-frequency drone that feels almost subsonic. The kind of sound that makes you check if something is wrong with your speakers. Then the voice begins. Quiet, distant, cold, deliberate. Each word carefully placed, not rushed, never rushed. There are places in the universe where warmth has never existed. Not in billions of years, not since the beginning. Places where heat died so long ago that the concept itself seems foreign, theoretical. Something that belongs to other regions of space, other times, but not here, not in these places, where nothing moves, where nothing survives, where existence itself struggles to continue. We think of cold as discomfort, a winter night when you forgot your coat, a frozen lake that makes your fingers numb, an early morning where your breath turns to mist. Something temporary, something you can escape by going inside, by lighting a fire, by wrapping yourself in layers. Something that ends. But that is not real cold. That is barely cold at all. That is warmth compared to what exists beyond our atmosphere, beyond our star's influence, beyond the comfortable bubble we have lived in our entire evolutionary history. Real cold is not something you feel. It is something that erases you, slowly, systematically, completely, without witness, without record, without anyone ever knowing you were there. The coldest places in the universe are not places you visit and return from. They are not destinations. They are not environments you survive and tell stories about later. They are places where existence itself becomes questionable, where atoms slow to the point of near stillness, where motion stops, where even light seems hesitant to pass through. These places do not kill quickly with violence or drama. They kill by absence, by taking everything away, 1 degree at a time, 1 joule of energy at a time, until nothing remains, until even the memory of warmth seems impossible. We live on a planet warmed by a star, wrapped in an atmosphere that traps heat like a blanket, protected by a magnetic field that shields us from radiation, insulated by layers of air that distribute warmth and maintain stable temperatures, surrounded by an ecosystem that generates and recycles energy. We have never known true cold, not in our species' entire history, not even close. We have never been far enough from heat to understand what happens when it disappears entirely, when there is no sun to warm you, no fire to huddle around, no shelter to retreat into. Just the infinite capacity of space to absorb heat and give nothing back. The coldest temperature ever recorded on Earth was in Antarctica, at a research station called Vostok in 1983. Minus 89.2 degrees Celsius. The scientists there could barely function. Their equipment failed constantly. Fuel froze solid in the lines. Rubber became brittle and shattered. Metal contracted and cracked. Breathing the air felt like inhaling glass shards that tore at the delicate tissue of their lungs. They could only work outside for minutes at a time before retreating to heated shelters. And yet that temperature, brutal and deadly as it was, is incomparably warm compared to what exists beyond our planet. That cold is nothing. A mild inconvenience. A summer day compared to the cold that waits in space. The universe has known true cold. And it remembers. In the voids between galaxies where no star has ever shone. On planets that drift alone through darkness, without a sun, without light, without hope of ever feeling warmth again. In clouds of gas expanding into nothingness, cooling as they spread, approaching temperatures that should not be possible. In the theoretical limit where motion itself ceases and time loses meaning, and the concept of temperature becomes abstract. Cold waits there, patient, inevitable, eternal. Not as a force, not as an attacker, not as something that hunts or pursues, but as the natural state of a universe that is slowly dying, cooling, fading into darkness and stillness, approaching equilibrium, approaching silence, approaching nothing. This is not a story about survival, because survival is not possible in these places. Not for a second, not for a moment, not with any technology we currently possess or can imagine possessing. This is a story about absence, about what the universe becomes when heat dies, about the places where cold has already won, where the battle ended billions of years ago, where warmth is not just absent but forgotten, where the universe has settled into its true nature, and what those places tell us about where everything is heading. Because the cold is spreading, the universe is getting colder, every year, every century, every billion years, and there is nothing that can stop it, no force that can reverse it, no mechanism to bring heat back once it has radiated away into the void. We misunderstand cold. Fundamentally, at the most basic level, we think of it as a thing, a substance, a force, something that attacks, something that invades. We say the cold gets in, the cold penetrates, the cold kills, as if it were an active presence, a predator stalking through the winter night, an enemy that can be fought or defended against. But that is wrong, completely wrong. Cold is not a presence, it is an absence. The absence of heat, the absence of motion, the absence of energy. Cold does not enter a room, heat leaves it. Cold does not attack your body. Your body loses the energy keeping it alive, radiates it away, gives it up to the environment. There is no such thing as cold, technically. Not as a substance, not as a force, not as anything that exists independently. There is only heat, thermal energy, molecular motion, and the lack of it. Heat is molecular movement. At the most fundamental level, temperature is just motion, nothing more, nothing less. Atoms vibrating, electrons spinning in their orbits, particles colliding with each other constantly, transferring kinetic energy back and forth. When something is hot, it is alive with motion, chaotic, energetic, active. The molecules are bouncing off each other thousands of times per second, creating pressure, generating what we perceive as warmth. The faster they move, the hotter the substance. The more energy is present, the more work can be done. When something is cold, that motion slows. The vibrations weaken. The collisions become less frequent, less energetic. The energy dissipates into the surrounding space, spreading out, diluting, becoming less concentrated. And when the motion stops entirely, when every particle becomes perfectly still, that is absolute zero, the coldest possible temperature in the universe, minus 273.15 degrees Celsius, 0 Kelvin, the point where physics itself seems to pause, where time becomes abstract, where the concept of temperature loses meaning because there is no motion left to measure. No kinetic energy to quantify, just stillness, perfect stillness, eternal stillness. On Earth, we never experience this, not even close, not even in the same universe of experience. Our planet is bathed in radiation from the sun, 1,300 watts per square meter hitting the Earth's upper atmosphere, warmed constantly by a star that has been burning for over 4.5 billion years and will continue burning for billions more. Protected by an atmosphere that traps that heat through the greenhouse effect and distributes it through convection and weather systems. Insulated by oceans that store enormous amounts of thermal energy and release it slowly, moderating temperature swings. Heated from within by radioactive decay in the Earth's core that keeps the planet's interior molten and drives tectonic activity. Even our coldest winters, our frozen poles where the sun does not rise for months, our deepest oceans where sunlight never reaches and the pressure is crushing, are incomparably warm compared to the universe beyond. Antarctica, at its coldest, at that record-setting minus 89 degrees, is still a furnace compared to deep space, still filled with molecular motion, still warm enough for chemical reactions to occur, just very slowly, still far, unimaginably far, from true cold. From the cold that exists in the space between stars, the cold that exists in the voids between galaxies, the cold that represents the baseline state of the universe when there is nothing to generate heat, when there is no star nearby, no planet, no matter at all, just empty space at its natural temperature, which is very, very cold. In space, there is no atmosphere to trap heat, no insulation, no protection, no mechanism to hold energy in place. Heat radiates away into the void as electromagnetic radiation, as infrared waves spreading out in all directions at the speed of light. Endlessly, relentlessly, silently, and nothing replaces it, nothing comes back. The void does not give, it only takes. Space is the perfect insulator in one sense because it is a vacuum and cannot conduct heat through physical contact. But it is also the perfect heat sink because anything with temperature above absolute zero will radiate energy away forever, until it cools to match the background temperature, until equilibrium is reached, until there is no more energy to give. A human body in space would not freeze instantly. That is a myth, a common misunderstanding perpetuated by movies and television and popular imagination. Freezing requires something to conduct heat away quickly, a medium to transfer energy through direct contact. Water, air, metal, something. Space is a vacuum. There is nothing there to conduct, nothing to touch, nothing to draw heat away through physical interaction. The vacuum itself is neither hot nor cold. It has no temperature because it has no particles, no matter to vibrate, no substance to measure. Instead, the body would radiate heat, slowly, over hours. The warmth generated by metabolism, by the chemical reactions keeping you alive, by the oxidation of glucose in your cells, would escape as infrared radiation, as photons carrying energy away from your skin, spreading out into the emptiness, dissipating, lost forever. The water in your cells would begin to freeze gradually, ice crystals forming inside tissue, sharp, jagged, expanding as they solidify because water expands when it freezes, rupturing cell membranes, destroying the delicate structures that make life possible, the lipid bilayers, the protein channels, the organelles, tearing through muscle fibers, through blood vessels, through organs, through the neurons in your brain, shredding the physical substrate of consciousness. But you would already be dead long before that happened. Long before the freezing became relevant, not from cold, not from ice formation, from asphyxiation, from the absence of oxygen, from decompression, from the violence of vacuum pulling the air from your lungs, because the pressure differential between your body and space is enormous, from your blood boiling at body temperature, because there is no atmospheric pressure to keep it liquid. The dissolved gases in your bloodstream would form bubbles, embolisms blocking circulation. Your lungs would collapse or rupture depending on whether you tried to hold your breath. Your tissues would swell as the water in them tried to vaporize. You would lose consciousness within 15 seconds as the oxygen in your brain was depleted. You would be brain dead within 2 minutes, and your heart would stop shortly after. Cold would be secondary, an afterthought, a final indignity inflicted on a body that had already stopped functioning. That was already dead. Frozen would be your final state, but not your cause of death. But on a rogue planet, far from any star, drifting alone through the darkness of interstellar space with no sun and no hope of ever finding one, cold is not secondary. It is everything. It is the defining characteristic of existence. It is the only force that matters, the only thing that shapes the environment, and it operates without pause, without mercy, without end, without any mechanism to relieve it or reduce it or escape from it. Cold does not destroy in a moment of violence like vacuum or radiation. It does not kill quickly. It destroys through patience, through relentless, unceasing extraction, through the quiet theft of every joule of energy, every calorie, every quantum of heat, until nothing remains, until molecular motion stops, until chemistry ceases, until even the atoms themselves seem to give up and settle into their lowest possible energy state. And in the coldest places in the universe, that process has been happening for billions of years, uninterrupted, unchallenged, complete. These are not places where cold is coming, where winter is approaching, where temperatures are dropping. These are places where cold has already won, where the battle ended long ago, where heat is a distant memory, a concept, something that once existed elsewhere, in some other region of space, in some other epoch of time, but not here, not now, not ever again. The cold in these places is permanent, eternal, final. There is no spring coming, no thaw, no warming trend, just cold, forever. Look up at the night sky on a clear evening. Get away from city lights if you can. Away from the orange glow of civilization. Away from the light pollution that obscures most of the stars. Find a dark place, a field, a mountain. Somewhere the sky opens up, the stars you see scattered across the darkness, thousands of them visible to the naked eye, if conditions are right, are close. Neighbors in cosmic terms, members of our galaxy. The Milky Way contains hundreds of billions of stars, possibly as many as 400 billion, and all of them are clustered together in a rotating disk about 100,000 light-years across. Relatively close, relatively dense, separated by light-years, yes. Distances incomprehensible to human experience. Distances we cannot travel with current technology. Distances that make our solar system seem tiny, but gravitationally bound, connected, part of a structure, a family, a system. When you look at the night sky, you are seeing your galactic neighborhood, a tiny fraction of the Milky Way, the stars visible to the naked eye, all 6,000 or so of them that can be seen from Earth under perfect conditions, are all within a few thousand light-years of our solar system. Most are much closer, within a few hundred light-years. A microscopic portion of the galaxy's 100,000 light-year diameter. You are seeing the local area, the nearby region, the cosmic equivalent of your street, your town, the stars you recognize, the constellations you name, Orion, the Big Dipper, Cassiopeia. All of them are local stars, neighbors, close enough that their light reaches us within a few thousand years. Close enough to be part of our shared region of space, but between galaxies there is something else entirely, something vast and empty and terrifying, something that does not appear in our night sky because it is too far away, too empty, too dark, voids, cosmic voids, super voids, regions of space so empty that galaxies themselves, massive structures containing hundreds of billions of stars each, structures so large they take light 100,000 years to cross, are rare, isolated, separated by incomprehensible distances. These voids are not just empty space between galaxies, not just gaps, not just the absence of matter in a few places. They are structures, features of the universe's large-scale architecture, the cosmic web, stretches of nothingness hundreds of millions of light-years across, some extending for over 1 billion light-years. The largest known structure in the universe is a void, the KBC void, named after its discoverers, 2 billion light-years across, a region of space so empty that if you were placed at its center, you would be 1 billion light-years from the nearest galaxy in any direction. Think about that. 1 billion light-years, light traveling at 300,000 kilometers per second for 1 billion years. That is the distance to the nearest galaxy. From where you are in any direction, you could look north, nothing. East, nothing. South, nothing. West, nothing. Up, nothing. Down, nothing. Just emptiness, darkness, void. A region where, if you were somehow placed there, you could look in any direction for the rest of your life and see almost nothing. Maybe a faint smudge on the horizon of detectability if you had instruments sensitive enough. Maybe, but probably not. Probably just nothing. No stars, no planets, no gas clouds glowing with the light of newborn suns, no galaxies nearby, none bright enough to see without the most powerful telescopes, no nebulae, no supernovae, no quasars, no pulsars, no anything, no light except the faintest possible glow of the cosmic microwave background. Just space, empty space, expanding, cooling, darkening, forever. The temperature in these voids is barely above absolute zero, around minus 270 degrees Celsius, 2.7 Kelvin. Only 2.7 degrees warmer than the coldest temperature theoretically possible in the universe. This is not speculation. This is not a guess. This has been measured, calculated, verified through multiple independent methods. This is the baseline temperature of the universe, the temperature that space itself approaches when there is nothing to warm it. No stars radiating energy across the electromagnetic spectrum, no galaxies emitting light, no matter colliding and generating heat through friction, no supernovae exploding, no black holes accreting matter and releasing X-rays. Nothing. Just the faint afterglow of the Big Bang, the cosmic microwave background radiation, a ghost of ancient heat, an echo of the universe's violent beginning 13.8 billion years ago. The cosmic microwave background is everywhere. It fills the entire universe. It is what remains of the intense heat of the Big Bang. When the universe was young, seconds old, it was incredibly hot. Trillions of degrees, hot enough that matter could not form. Only energy, only radiation. A seething plasma of particles and antiparticles and photons all colliding and annihilating and reforming constantly. But as the universe expanded, it cooled. The energy spread out, diluted. After 380,000 years, it had cooled enough for atoms to form, for electrons to bind to nuclei, for matter to become neutral. And at that moment, the universe became transparent. The photons that had been trapped in the plasma were suddenly free to travel, and they have been traveling ever since, for over 13 billion years, stretched by the expansion of space. Red shifted from visible light to microwaves, cooled from thousands of degrees to 2.7 Kelvin, barely above absolute zero, and that faint glow is still fading. Every year that passes, the cosmic microwave background gets a little colder, a little fainter, a little more diluted. The universe is expanding, space is growing, and as it grows, the energy within it spreads thinner. The photons get stretched to longer wavelengths. Lower frequencies, lower energies, the temperature drops. Currently, it is 2.7 Kelvin. In 1 trillion years, it will be colder. In 100 trillion years, colder still. Eventually, far in the future, so far that the numbers become meaningless, it will be undetectable. Cooled below the point where any instrument, no matter how sensitive, could measure it. And the universe's baseline temperature will drop even further, approaching absolute zero, asymptotically, forever. Never quite reaching it because of quantum mechanics, because of zero-point energy, because of the fundamental limits of physics, but close enough that the difference is academic, philosophical, irrelevant to any practical measurement. In a cosmic void, if you could somehow exist there, if you could somehow be placed in the center of one of these vast empty regions with nothing around you for hundreds of millions of light years in every direction, you would be alone in a way that is incomprehensible, truly alone. Not alone like being in a desert where you can still see the horizon and know that civilization exists somewhere beyond it. Not alone like being at sea where at least you are surrounded by water and life exists beneath you, and the sky is above you, and land exists somewhere even if you cannot see it. Not alone like being in Antarctica where you are isolated but still on Earth, still part of a planet, still connected to humanity even if separated by distance. This would be different, fundamentally different, ontologically different. The nearest galaxy would be so distant that its light would take hundreds of millions of years to reach you. And that light would be faint, so faint, red shifted by the expansion of space, stretched to longer wavelengths, dim by distance, barely distinguishable from background noise. You would need instruments to detect it at all. Your eyes, even if they could somehow survive and function in that environment, would see nothing, just blackness, complete blackness. The kind of black that human eyes have never experienced, the kind of black that makes you question whether your eyes are even open, whether they are even working, because there is nothing to see. No photons entering your retinas, no stimulation of your optic nerve, just the random firing of neurons in the absence of input. Phosphonies, imaginary lights created by your brain to fill the void. If you looked in any direction, you would see almost nothing. Perhaps if you had a telescope powerful enough, if you had sensors sensitive enough, if you had the patience to integrate light for hours or days or weeks, you might detect a few faint smudges, distant galaxy clusters, structures so far away that their light has been traveling longer than complex life has existed on Earth. Too far to ever reach, too far to matter, too far to provide any sense of connection or hope or meaning. You would be surrounded by darkness, absolute darkness, unbroken darkness. A darkness so complete that the concept of light becomes abstract, theoretical, something that exists elsewhere, in other regions of space, in galaxies and stars and planets, but not here, not in the void. The darkness would be total, not the darkness of a moonless night on Earth, which is actually illuminated by starlight and air glow and zodiacal light and the faint glow of the Milky Way and the lights of distant cities reflecting off the atmosphere. Not the darkness of a cave deep underground, which is at least surrounded by earth, by rock, by the proximity of the surface somewhere above, by the knowledge that light exists just beyond the stone. This would be the darkness of true cosmic emptiness. Nothing around you in any direction for hundreds of millions of light years. No matter, no energy, no structure, just space, empty, expanding, cold. And the cold would be just as absolute, just as overwhelming, just as inescapable. No sun to warm you, no nearby stars within hundreds of millions of light years. No radiation except the infinitesimally faint whisper of the cosmic microwave background. 2.7 Kelvin, minus 270 degrees Celsius. Your body would radiate its heat into the void. Every second, infrared radiation would leave your skin, photons carrying energy, spreading out in all directions, into nothingness, never absorbed by anything, never reflected back, never encountering anything at all, just lost, forever, and nothing would replace it. No external source of warmth, no star, no fire, no other body nearby sharing heat through radiation. Nothing. You would cool, slowly, inevitably, inexorably. Your molecules slowing as the energy that animated them dissipated into space, your cells crystallizing as the water within them froze into ice, your consciousness fading into a frozen stillness as your brain cells stopped functioning, stopped firing, stopped being alive, and no one would ever know. Because in a cosmic void, there is no one to know. No observers, no witnesses, no rescue mission, because no one knows you are there, and even if they did, they could never reach you. No possibility of discovery, because you are too far from anything, too isolated, too alone. Just emptiness, expanding, forever. You would die. Your body would freeze, and you would drift. A frozen corpse drifting through a void for eternity, never encountering anything, never being found, never decaying because there is nothing to cause decay. No bacteria, no oxygen, no moisture, just preservation, perfect preservation, a frozen body drifting through nothing, forever. Time in a cosmic void is meaningless in a way that is difficult to articulate, difficult to comprehend. On Earth, time is measured by change, by the sun rising and setting, by seasons changing as the Earth orbits the sun and its axis tilts relative to the ecliptic, by the growth and decay of living things, by the motion of the moon through its phases, the rhythm of tides driven by lunar gravity, the cycles that mark progression, that give time meaning, that make it concrete. But in a void, none of that exists. There is no change, no cycles, no events. Millions of years pass without a single thing happening, without anything at all occurring. The void does not evolve. It does not grow or diminish in any meaningful sense that matters. It simply exists, cold, dark, silent, unchanged, unchanging, a permanent state, an eternal condition, a frozen moment stretched across billions of years. And it will continue to exist long after every star in the universe has burned out. Long after galaxies have drifted so far apart that they can no longer see each other even with the most powerful instruments. Long after the last black hole has evaporated into Hawking radiation through quantum tunneling effects at the event horizon. Long after the last proton has decayed, if proton decay is real. Long after everything that can happen has happened, and the universe has reached its final equilibrium state, the voids will remain, colder than they are now, darker than they are now, emptier than they are now. the final resting state of the universe, the end state, the place where everything is heading. Because the universe is not static, it is changing, evolving, cooling, expanding, and the voids are growing. And we are watching it happen right now, in real time. The universe is expanding, not just growing, but accelerating. The rate of expansion is increasing, driven by something we call dark energy, because we do not understand it, and we do not know what it is, and we needed a name, so we called it dark energy, a mysterious force or property of space itself that pushes everything apart. That works against gravity. That causes the expansion to speed up rather than slow down. Galaxies are moving away from each other, the distances between them growing, and as they move apart, the voids expand. The empty regions get larger. They consume more space. They fill more of the universe with their emptiness. Eventually, trillions of years from now, every galaxy will be isolated, surrounded by nothing, separated from every other galaxy by distances so vast that light cannot cross them, unreachable, alone. Each galaxy an island in a universe that has become one vast cosmic void, cold, dark, silent, forever. This is not speculation. This is not science fiction. This is not a worst-case scenario or an unlikely possibility. This is projection based on observation, on measurement, on the behavior of space itself that we have been tracking for decades. The universe is not winding down into some warm, comfortable equilibrium. It is not reaching a stable state where everything is balanced and peaceful. It is cooling, dispersing, diluting into nothingness. Heat is spreading out. Energy is dissipating. Structure is dissolving. The stars will burn out. The galaxies will drift apart. The black holes will evaporate. And what will remain is void. Cold void, dark void, empty void. The voids are the truth. They are the reality beneath the temporary complexity we see around us. They are what the universe becomes when left alone long enough. When the temporary burst of energy from the Big Bang has finally dissipated. When the stars have burned out. When the galaxies have drifted apart beyond any possibility of interaction. What remains is void, cold, empty, eternal, and growing. Not all planets orbit stars. This is a fact that most people do not think about. When we imagine planets, we imagine them circling suns, part of solar systems, illuminated, warmed, part of a structure. But most planets in the universe probably do not orbit stars. Most are alone. Rogue planets, orphans of planetary formation, cast out from their star systems by gravitational interactions early in their development, by the chaotic dance of young planets jostling for stable orbits in the protoplanetary disk, by near collisions that did not quite result in impact but transferred enough momentum to eject one of the planets entirely, by instabilities, by resonances, by the gravitational influence of a passing star disrupting the system, thrown violently into the darkness of interstellar space with enough velocity to escape their sun's gravity forever, achieving escape velocity. And once they leave, they never return. They cannot return. Their trajectory carries them away, forever. They drift, through the cold between stars, no sun to warm them, no light to illuminate them, no connection to anything, just frozen worlds moving silently through the void, alone, always alone. Scientists estimate there may be billions of rogue planets in our galaxy alone. Conservative estimates suggest at least as many rogue planets as stars. Some estimates go much higher, trillions. More rogue planets than stars. A hidden population of frozen worlds that we cannot easily detect because they emit no light. They do not shine. They do not glow. They have no nearby star to reflect light from. They are invisible, lost in the darkness, drifting through interstellar space completely unnoticed, unobserved, unknown. We have only recently begun to detect a few of them through gravitational microlensing, a technique where we watch distant stars and look for brief, temporary increases in brightness caused by an object passing between us and the star. When a rogue planet passes in front of a distant star from our perspective, its gravity bends the starlight slightly, acts as a lens, magnifying the star's light temporarily, creating a brief flicker, a brightening that lasts hours or days. And from that flicker, from the shape of the light curve and the duration of the event, we can infer the planet's existence, its approximate mass, its trajectory, but we cannot see it, cannot image it, cannot photograph it, cannot study it in detail. It is there, and then it is gone, back into the darkness, back into invisibility. Imagine standing on the surface of a rogue planet. Try to truly picture it, to visualize the experience, the reality of what it would be like. Not as an abstract thought exercise, but as a genuine attempt to understand what that environment would be. The sky above you is black, completely black. Not the black of a moonless night on Earth when clouds cover the stars. Not even the black of deep space as seen from orbit, where at least you can see thousands of stars in the band of the Milky Way stretching across your field of view. True black, absolute black, the black of a void. No sun, no moon, no nearby stars within light years that are bright enough to cast even the faintest illumination. Just darkness, total, unbroken, oppressive, crushing. The kind of darkness that makes you question your sanity, that makes your visual cortex fire randomly in search of input. You could hold your hand directly in front of your face, centimeters from your eyes, and see nothing. No outline, no shadow, no silhouette, nothing. The darkness would be so complete that your eyes would search desperately for any photon, any hint of light, any visual information at all, and find none. Just endless black in every direction. A blackness so absolute it feels like a physical presence, like something pressing against you. The ground beneath you is frozen solid, harder than steel, harder than diamond, colder than anything on Earth, colder than the coldest laboratory, colder than liquid nitrogen, colder than liquid helium. If the planet once had an atmosphere, and many rogue planets probably did when they were part of a star system with enough warmth to keep gases in gaseous form, it has long since condensed, frozen, fallen from the sky. The temperature dropped as the planet drifted away from its star. The gases cooled, and eventually nitrogen and oxygen and carbon dioxide and methane and whatever else was in the atmosphere reached their condensation points, became liquid, then froze solid, and fell as snow, as frozen rain, as crystals settling onto the surface, accumulating in drifts, freezing into ice, buried under layers of frozen atmosphere meters thick, possibly kilometers thick, depending on how dense the atmosphere was and how long the planet has been freezing. The surface would be smooth in places, glassy, like frozen glass but harder, rough in others where the frozen atmosphere accumulated unevenly. Drifts of frozen nitrogen, ridges of solid oxygen, plains of carbon dioxide ice, all reflecting nothing because there is no light to reflect. Just a frozen crust covering a dead world, a tomb. The temperature is unimaginable to human experience, minus 200 degrees Celsius, or colder, much colder, depending on how long the planet has been adrift, how many billions of years it has been since it felt the warmth of a sun, since it was close enough to a star to receive any radiation at all. The planet's internal heat, the residual warmth from its formation when the material that made it was compressed by gravity and heated by the energy of countless collisions, and the heat from radioactive decay of uranium and thorium and potassium in the planet's core, radiates slowly into space, escaping, lost, never replaced. The surface temperature approaches the background temperature of interstellar space, minus 270 degrees, approaching absolute zero, asymptotically, forever, getting closer but never quite reaching it. Your body, if it were somehow on that surface, if you were somehow standing there in a spacesuit or exposed directly, would freeze in minutes. Not from contact with the ground alone, though that would be instantly lethal if you touched it because thermal conductivity would draw heat out of you faster than your body could generate it. But from radiation, from heat leaving your body in all directions as infrared radiation, faster than it could be generated by metabolism, faster than any biological process could replace it. Your skin would crystallize, freeze solid. Your blood would freeze in your veins. your tissues would solidify, turn to ice, and your consciousness would fade into nothing as your brain cells stopped functioning, stopped firing action potentials, stopped processing information, stopped being alive. You would die aware of the cold, aware of the darkness, aware of the isolation, and then you would stop being aware of anything, forever. But the cold is not the worst part. That might seem impossible to believe. Minus 200 degrees, instant death, frozen solid in minutes. What could possibly be worse than that? But there is something worse, much worse. The isolation, the knowledge, the awareness, in your final moments before freezing, steals your thoughts and your consciousness fades into nothing. That you are on a world that will never see a sunrise, that will never feel warmth again, that has no hope, no future, no possibility of change, that is drifting through space with no destination, no purpose, no meaning, no end. Just motion, slow motion, eternal motion, meaningless motion. This planet is not going anywhere. It is not heading toward another star. It is not on a journey with a destination. It is not going to be rescued or rediscovered or warmed again. It is simply moving through the galaxy at whatever velocity it was ejected with billions of years ago when it was thrown out of its birth system. Drifting forever, through the space between stars, through regions of the galaxy where stars are sparse, where the distance between them is measured in light years, where you could travel for centuries at relativistic speeds and still not encounter another star. And this planet is not traveling at relativistic speeds. It is moving slowly, tens of kilometers per second, fast by human standards, slow by cosmic standards. It would take hundreds of thousands of years to travel a single light year, millions of years to reach the nearest star from wherever it happens to be. And it is not heading toward any particular star. It is just moving, in whatever direction it was thrown, forever. Rogue planets do not orbit. They have no year. They do not have seasons. They do not have cycles. They do not return to any starting point. They do not have any reference point that marks time in a meaningful way. They exist in a permanent state, frozen, dark, unchanging. A single moment stretched across eternity, stasis, permanence. Time on a rogue planet is measured not in days or years. There are no days. The sun does not rise because there is no sun. The planet might be rotating. Most planets do. But it does not matter. There is no sun to create day and night, no star to mark the passage of rotation. Just endless darkness, whether the planet is spinning or tidally locked or tumbling chaotically. It makes no difference. There are no years, no orbit, no return to a starting point, no seasonal cycle, nothing to mark the passage of time except the slow cooling of the planet's interior, the gradual radioactive decay of elements, the patient, inexorable approach toward thermal equilibrium with interstellar space. Time is measured in eons, billions of years of drifting, through the space between stars. Occasionally, very occasionally, perhaps once every few million years or tens of millions of years depending on the local stellar density, passing near another star, entering its outer gravitational influence, feeling a slight tug, a slight deflection in trajectory, getting close enough to receive a tiny, infinitesimal amount of radiation, close enough that the surface temperature might increase by a few degrees, from minus 200 to minus 190, negligible, meaningless, undetectable without instruments, a brief moment of relative warmth compared to the endless cold, and then past, trajectory altered slightly, but still drifting, back into the darkness, back into the cold, forever. No possibility of capture. The rogue planet is moving too fast, its velocity too high, the star's gravity insufficient to slow it enough to establish an orbit. It just passes and continues, and the cold returns. Some rogue planets, and this is one of the most disturbing possibilities that scientists have seriously considered, may have oceans beneath their frozen surfaces. Subsurface oceans, liquid water, not on the surface. The surface is far too cold for liquid anything. Water, nitrogen, oxygen, carbon dioxide. Everything is frozen solid. Ice. But deep underground, insulated by kilometers of ice and rock, heated by the planet's own residual internal heat. There could be liquid water, a dark ocean, sealed away from the universe, trapped beneath an impenetrable frozen crust. The ice above would be kilometers thick, too thick to drill through, too thick for any light to penetrate even if there were light, too thick for any communication with the surface. A completely isolated environment, cut off from space, cut off from the universe, existing in its own sealed world. These subsurface oceans are heated not by a sun, because there is no sun, but by the planet's own internal processes, by radioactive decay in the core, uranium-238 decaying into thorium and releasing alpha particles and heat, thorium-232 decaying into radium, potassium-40 decaying into calcium and argon. These decays happen slowly, over billions of years, but they release heat. Enough heat to maintain a liquid ocean if the planet is large enough and the ice layer above is thick enough to insulate it. By tidal forces if the planet has a large moon, and the moon's gravity flexes the planet's interior as it orbits, generating friction and heat. Though most rogue planets probably lost their moons during the ejection event, the gravitational chaos that threw the planet out of its system likely also stripped away its satellites. But some might have kept them. Some might still have moons. And those moons would create tides in the subsurface ocean, flexing the ice, generating heat through friction, keeping the water liquid. By residual heat from the planet's formation, the energy of all those collisions that built the planet, the gravitational compression, the differentiation as heavy elements sank to form the core, that heat, trapped beneath kilometers of insulation, dissipating very slowly over billions of years, enough to maintain liquid water. These subsurface oceans could, theoretically, support life. This is not speculation. This is serious scientific hypothesis based on what we know about life's adaptability and the conditions that might exist on rogue planets. Microbial life, single-celled organisms, bacteria, archaea, extremophiles adapted to darkness, to cold, to isolation, to living without sunlight, without photosynthesis, feeding on chemical energy instead of solar energy. Chemosynthesis, using the chemical potential energy in compounds like hydrogen sulfide or methane or iron, oxidizing them, extracting energy, building organic molecules, reproducing, living. This is not hypothetical. We know this kind of life exists on Earth. In deep-sea hydrothermal vents where no sunlight reaches and the water is superheated by volcanic activity, in subglacial lakes beneath kilometers of Antarctic ice, Lake Vostok, Lake Whillans, isolated for millions of years, cut off from the surface, and yet they contain life, bacteria, living, reproducing, thriving in conditions we once thought were sterile, in the deepest parts of the ocean, in the crust of the Earth kilometers underground. In environments that seem impossible for life, life finds a way, life adapts. Life persists in the most inhospitable environments imaginable, and a subsurface ocean on a rogue planet, while extreme, is not necessarily sterile. It could support life, microbial life, simple life, but life nonetheless. Life that would never see the surface, never know that a sun exists anywhere in the universe, never experience light, never know about stars or planets or space or anything beyond the few cubic meters of water they inhabit. Just existence in the dark, in the cold, beneath kilometers of ice, on a world drifting alone through the void, generation after generation, reproducing, dying, continuing, in complete isolation, unaware of the universe around them, unaware that they are on a planet, unaware of anything beyond their immediate environment. But even if life exists there, think about what that means. Really think about it. It exists in a prison, trapped beneath ice kilometers thick, on a world with no connection to anything else, no possibility of escape, no possibility of ever reaching the surface even if they evolved intelligence and tools and technology, because the ice is too thick and there is no energy source sufficient to melt through it. No possibility of ever seeing another world, No possibility of communication with any other life in the universe because they are sealed away, isolated, cut off. No future beyond survival. No possibility of evolution into complex multicellular life because there is not enough energy in the system, not enough chemical potential, not enough food, just enough to support microbial ecosystems at low density, just enough for bare existence, for survival, but not for thriving, not for complexity, not for anything beyond the simplest forms of life. Just existence, generation after generation, billions of generations, trillions of generations, reproducing from parent cell to daughter cell, dying when resources run out or when random mutations make survival impossible, continuing when conditions allow, in the dark, in the cold, forever, unaware that they are part of one of the universe's greatest tragedies. Life that exists, that continues, but that has no future, no possibility, no hope, just survival, in the dark, alone, while the planet that contains them drifts through space carrying its sealed biosphere toward nothing, and the rogue planet continues its eternal drift, through the galaxy, for billions of years more, until the galaxy itself begins to disperse, until the stars burn out, until even the faint possibility of passing near another star disappears as stellar density drops and the space between stars grows and the galaxy spreads out. And the planet drifts into the growing voids between galaxies, colder than ever before, darker than ever, more alone than ever, carrying its hidden ocean, its imprisoned life, into the final darkness, the eternal cold, the endless void, where it will drift forever, or until the ocean finally freezes, until the last of the planet's internal heat dissipates, until the radioactive elements have all decayed, until equilibrium with interstellar space is reached, and the water turns to ice, solid ice, killing whatever life remained, entombing it, preserving it, a frozen fossil of a biosphere that no one will ever discover, no one will ever know existed, no one will ever study or learn from, just frozen cells in frozen water on a frozen world drifting through frozen space, forever. This is the fate of life on rogue planets. If it exists, if it ever existed, if it ever had a chance, isolation, imprisonment, and eventually extinction, not from violence, not from catastrophe, but from cold, from the slow, patient, inexorable cooling of a planet that has been drifting alone for too long. And we only recently realized these planets exist, only recently started detecting them, only recently understood that they outnumber the planets that orbit stars, that most planets in the universe are alone, frozen, dark, lost, drifting, forever. There is a place in space colder than anywhere else we have ever found. Colder than the voids between galaxies where the temperature is only a few degrees above absolute zero. Colder than rogue planets that have been drifting in darkness for billions of years. Colder than the background temperature of the universe itself, which is already almost as cold as anything can get. Colder than physics says it should be. It is called the Boomerang Nebula, and it should not exist, or rather, it should not be as cold as it is. The universe has a baseline temperature, the cosmic microwave background, 2.7 Kelvin, minus 270 degrees Celsius. That is as cold as empty space gets naturally when there is nothing around generating heat and nothing disturbing the equilibrium. That is the ambient temperature, the default, the floor. But the Boomerang Nebula is colder than that, significantly colder, 1 degree Kelvin, minus 272 degrees Celsius. And we do not fully understand why. We have theories, models, explanations that might be correct, but we are not certain. This is one of the most extreme environments we have ever observed, and it challenges our understanding. The nebula is a cloud of gas expelled from a dying star 5,000 light-years away from Earth in the constellation Centaurus. The star at its center is in its final stages of evolution, a red giant that has exhausted the hydrogen fuel in its core. Fusion has stopped or moved to a shell around the core. The core itself is collapsing under gravity, contracting, heating, while the outer layers are expanding, becoming unstable, pulsing, throwing off shells of gas into space. This is a normal process in stellar evolution. Stars like our Sun will do this eventually. In about 5 billion years, the Sun will become a red giant, will expand, will engulf Mercury and Venus, will possibly reach Earth's orbit, and will begin ejecting its outer layers, creating a planetary nebula, a beautiful expanding shell of gas illuminated by the hot core at the center. This is how stars die. Most stars, not the most massive ones which explode as supernovae, but stars like the Sun, medium-sized stars, they die quietly, gently, by expansion and ejection, leaving behind a white dwarf, a hot, dense core made of carbon and oxygen, slowly cooling, radiating away its remaining heat over trillions of years. But something about the Boomerang Nebula is different. Something unusual, extreme. The gas is expanding fast, much faster than normal for a planetary nebula, at 600,000 kilometers per hour, 15 times faster than typical, and as it expands, it cools. This is normal thermodynamics, adiabatic cooling. When a gas expands, it does work against its own pressure, pushing outward. That work requires energy, and that energy comes from the internal thermal energy of the gas itself, the kinetic energy of the molecules. They slow down, the temperature drops. This is how refrigerators work, how air conditioning works. Compress a gas and it heats up. Let it expand and it cools down. But in the Boomerang Nebula, this process is extreme. The expansion rate is so high that the cooling effect is dramatically amplified beyond anything normal. The gas is essentially refrigerating itself through rapid expansion, cooling below the ambient temperature of space around it, creating a region colder than the universe, an anomaly, a pocket of extreme cold that should not be possible but is. The temperature in the densest parts of the Boomerang Nebula, in the heart of the expanding gas cloud, has been measured at 1 Kelvin, 1 degree above absolute zero, 1 degree warmer than the coldest temperature theoretically possible in the entire universe. This is not a theoretical calculation. This is not a model or a simulation based on assumptions. This has been measured directly using radio telescopes, the Atacama Large Millimeter Array in Chile, one of the most sensitive radio telescope arrays in the world. They measured the emission spectrum of carbon monoxide molecules in the nebula. Carbon monoxide emits radiation at specific frequencies depending on its temperature. By analyzing that emission, scientists could determine the temperature, and it was 1 Kelvin, confirmed by multiple independent observations using different instruments and different methods. The coldest natural place we have ever detected in the observable universe, colder than interstellar space, colder than the cosmic microwave background radiation that fills the universe, a pocket of extreme unnatural cold floating in an already cold cosmos. Scientists are not entirely certain why the Boomerang Nebula is this cold. The leading theory, the one that most researchers accept as the best explanation we currently have, is that the gas is expanding unusually fast and that the expansion is causing extreme adiabatic cooling. But why is it expanding so fast? That is less clear. Perhaps the dying star at the center underwent some unusual event, a thermal pulse, a sudden burst of fusion in the shell around the core that ejected material more violently than normal. Perhaps the star has a companion, a binary partner whose gravity is accelerating the ejection. Perhaps the geometry of the outflow is unusual. The gas is being ejected in two opposite directions, like a bipolar flow, rather than expanding spherically. This could concentrate the cooling effect, make it more extreme, but we do not know for certain. We have hypotheses, educated guesses based on observations and theoretical understanding. But the Boomerang Nebula remains somewhat mysterious, an outlier, an extreme case that pushes the boundaries of what we thought was possible. But there may be other factors we have not considered, other processes at work, the density of the gas in the nebula. If it is denser than typical planetary nebulae, more mass packed into a smaller volume, that could enhance the cooling effect. More molecules colliding, more opportunities for energy to be transferred and radiated away. The specific elements present in the gas, carbon, oxygen, nitrogen. Different elements radiate energy at different rates. Carbon monoxide is particularly efficient at radiating energy as infrared photons. If the nebula has a high concentration of carbon monoxide, that could enhance cooling. The geometry of the expansion. The shape. Bipolar flows behave differently than spherical expansions. The gas streams out in jets, fast, directed. This could create different thermodynamic conditions. The interaction with the star's remaining radiation. The dying star at the center is still emitting some light, some heat, but perhaps not enough to warm the rapidly expanding gas. Perhaps the expansion rate is so high that the gas is moving away faster than the star's heat can warm it. Or perhaps there are other processes, magnetic fields, shock waves, interactions with the surrounding interstellar medium. We do not fully understand all the factors, but something about this particular dying star in its particular death, in the particular way its outer layers are being expelled, is creating conditions that push temperature to its absolute limit, to 1 degree above the theoretical minimum, to the edge of what is physically possible. And we are watching it happen, observing a natural astrophysical process that creates cold so extreme it approaches the boundary where motion itself almost ceases. At 1 Kelvin, at 1 degree above absolute zero, molecules barely move at all. They still have some kinetic energy, some motion, but it is minimal, infinitesimal compared to room temperature. At room temperature, roughly 300 Kelvin, molecules in air are moving at hundreds of meters per second, colliding billions of times per second, creating pressure, creating sound, creating all the phenomena we associate with gases. At 1 Kelvin, those same molecules would be moving at less than 1 meter per second, barely drifting, colliding rarely, almost still. Any chemical reactions would be impossibly slow. Reactions require collisions, require molecules to meet with enough energy to overcome activation barriers. At 1 Kelvin, there is no energy, no collisions, no reactions. Chemistry has essentially stopped. Biological processes would be utterly impossible. Not just difficult, not just improbable. Impossible. Life, in any form we understand or can even theoretically imagine, could not exist at 1 Kelvin. Not even for a nanosecond. Not even in principle. If a human body were somehow placed in the Boomerang Nebula, somehow transported there instantly, it would not survive long enough to freeze in any conventional sense. The cold would be so extreme, so immediate, so fundamentally beyond anything biological systems can withstand, that death would be instantaneous. Not gradual, not over seconds or minutes. Instantaneous. Your cells need to maintain certain chemical reactions to stay alive. Enzymes need to function. Ion channels need to operate. Electrical signals need to propagate along neurons. ATP needs to be synthesized and hydrolyzed to provide energy for cellular processes. All of these processes require molecular motion, require kinetic energy, require temperatures far, far, impossibly far above 1 Kelvin. At 1 degree above absolute zero, none of these reactions can occur. The molecules cannot move, the enzymes cannot change shape, the ion channels cannot open or close, the electrical signals cannot propagate because the ions needed to carry charge are not moving. Your heart would stop. Not because it froze, not because ice crystals formed and ruptured cells, but because the biochemistry required for muscle contraction simply cannot happen at that temperature. The actin and myosin proteins in your heart muscle need to slide past each other. That requires molecular motion. That requires energy. That requires heat. At 1 Kelvin, there is none. Your heart stops instantly, your brain stops. The neurons that were just moments ago processing thoughts and perceptions and consciousness cease firing action potentials. The sodium and potassium ions that need to flow across cell membranes to create electrical signals are frozen in place. Not literally frozen as ice, but frozen in motion, unable to move, unable to function. Consciousness vanishes, not fades, vanishes, in literally zero time. One moment you exist, the next moment you do not. And there is no transition, no awareness of dying, no final thought, just cessation. And then, over the following picoseconds and nanoseconds and microseconds, your body would begin to freeze in the conventional sense. The water in your cells solidifying, but you would already be gone, dead before your brain could even process what was happening, before a single neural signal could propagate, before anything at all could occur. The Boomerang Nebula represents something deeply unsettling about the universe. It shows us that natural processes, without any technological intervention, without any artificial manipulation, can create conditions more extreme than the background state of the cosmos. The universe's default temperature is 2.7 Kelvin, cold, almost as cold as possible. But the Boomerang Nebula is colder, 1 Kelvin, colder than the universe itself, colder than the space surrounding it, colder than anything else we have found. And it exists not because someone built a refrigerator or because some advanced civilization is conducting experiments, but because of a dying star, because of natural expansion of gas according to well-understood laws of thermodynamics. Because the universe, under certain conditions, in certain places, can create cold so extreme it reaches within 1 degree of absolute zero. The theoretical minimum, the floor, the boundary, and it makes you wonder what else might be out there. What other extreme conditions might exist in regions of the universe we have not yet observed, in corners we cannot see, in places too distant or too faint for our instruments to detect. The Boomerang Nebula was only discovered relatively recently, in the 1980 during initial surveys. Its extreme cold was only measured in the 1990s and confirmed in the 2000s. It is 5,000 light-years away, not that far in cosmic terms, in our own galaxy, the Milky Way, observable with modern telescopes, accessible to study. And yet we did not know it existed until recently, did not know it was the coldest known place in the universe until we measured it. What else is out there waiting to be discovered? What other pockets of extreme cold exist? Or extreme heat? Or extreme density? Or extreme anything? The universe is capable of creating conditions that challenge our assumptions about what is possible, that push the boundaries of physics, that approach theoretical limits. And the Boomerang Nebula is just one example, one data point, one measurement that tells us the universe can be colder than we thought, colder than the baseline, colder than what should be possible for empty space, cold enough to almost touch absolute zero, naturally, without intervention, just through the death of a star and the thermodynamics of expanding gas. And that raises a deeper question, the fundamental question: what is absolute zero? Not just as a number on a temperature scale, not just as minus 273.15 degrees Celsius or 0 Kelvin, but as a concept, as a state of being. What does it mean for something to be at absolute zero? What happens there? What is it like? Can it even be reached? Absolute zero is defined as the temperature at which all thermal motion ceases, when atoms stop vibrating, when molecules stop moving, when particles become perfectly still. This is the theoretical limit of coldness, the boundary beyond which temperature cannot go, because temperature itself is a measure of thermal energy, of kinetic energy at the molecular level. And when that energy is zero, there is nothing left to measure. 0 Kelvin, the coldest possible temperature in the universe. Not the coldest we have achieved, not the coldest we have measured naturally, the coldest that can exist according to the laws of thermodynamics. Period. Full stop. No colder is possible. But here is the profoundly disturbing part, the part that makes physicists uncomfortable, the part that reveals something fundamental about reality. We cannot reach absolute zero, not in practice, not even in theory. According to the third law of thermodynamics, it is impossible to cool any system to absolute zero in a finite number of steps. We can approach it, we can get close, arbitrarily close. In laboratories around the world, using sophisticated cooling techniques like laser cooling and evaporative cooling and magnetic cooling, scientists have achieved temperatures within billionths of a Kelvin above absolute zero, close enough that for most practical purposes, the difference does not matter, close enough that quantum effects dominate and matter behaves in bizarre ways. Bose-Einstein condensates, superfluids, superconductors, states of matter that do not exist at normal temperatures. but they cannot reach zero itself. They can get to 0.000001 Kelvin, to 0.00000001 Kelvin, to arbitrarily small positive temperatures, but never exactly zero. Something always prevents it. Some residual energy always remains, some quantum fluctuation, some fundamental limit built into the structure of reality itself that says this far and no farther. And even if we could reach absolute zero, even if we could somehow bypass the third law of thermodynamics and remove every last bit of thermal energy from a system, quantum mechanics tells us that motion does not completely stop. There is still zero-point energy, a minimum energy level that quantum systems possess even at absolute zero. A consequence of the Heisenberg uncertainty principle. You cannot know both the position and momentum of a particle with perfect precision. If a particle were truly at rest, perfectly still, its momentum would be exactly zero, and we would know it with infinite precision. Which means, according to the uncertainty principle, we would know nothing about its position. It could be anywhere in the universe. This is not physical, not allowed, so particles must have some minimum motion, some residual vibration. Even at absolute zero, they cannot be perfectly still and perfectly localized at the same time. Quantum mechanics forbids it. So absolute zero is not really zero, not really stillness, not really the absence of all motion. It is a limit, an asymptote, something we can approach mathematically but never actually reach physically. And even if we did reach it somehow, the quantum nature of reality would prevent true perfect stillness. But as a thought experiment, as a hypothetical, as a way to understand what cold means at its most extreme, imagine what it would be like at absolute zero. Imagine a region of space, or a laboratory, or a single atom cooled to precisely 0 Kelvin. Exactly zero. No thermal energy whatsoever, no motion, no vibration, no kinetic energy at any scale. What would that be like? What would exist there? Time, in a sense, would stop. Not literally according to general relativity. Time is a dimension of space-time, and it flows regardless of temperature. But thermodynamically, time would lose meaning. Because time as we experience it, as we measure it, as we understand it, is deeply connected to entropy, to the second law of thermodynamics, to the flow of energy from hot to cold, to the gradual dissipation of order into disorder. Heat flows from hot to cold, never the reverse. This gives time a direction, an arrow, past to future, lower entropy to higher entropy. But at absolute zero, there is no heat to flow, no energy gradient, no temperature difference anywhere in the system because everything is at the minimum possible temperature. No transfer, no change. The system is in its lowest possible energy state, and it cannot go lower because there is nowhere to go. Nothing to change into. It simply exists, frozen, static, eternal, not changing, never changing, unable to change. A single frozen moment that lasts forever because there is no mechanism for time to progress. No process to mark the passage. No entropy increase. Just stasis. Sound would be impossible. Not difficult, not faint. Impossible. Sound is a mechanical wave, a vibration of particles propagating through a medium, compression and rarefaction, areas of high pressure and low pressure traveling through matter. At absolute zero, the medium is not vibrating. The atoms are still, perfectly still. There is nothing to carry the wave, no mechanism for the compression to propagate, no way for the disturbance to travel. Silence would be total, perfect, absolute, not the silence of a quiet room where if you listen carefully you can still hear faint sounds, the hum of electronics, the vibration of pipes, the settling of structures, the distant murmur of traffic or wind or life. True silence. The absence of any possible sound because the physical mechanism required to create sound no longer functions. The medium has stopped. Light would still exist. Photons are not affected by temperature in the same way as matter. They can pass through a substance at absolute zero. Electromagnetic radiation does not require a medium. It can propagate through vacuum, through empty space, through matter at any temperature, but light would not be emitted. Thermal radiation, black-body radiation, requires motion, requires excited atoms, requires electrons jumping between energy levels and releasing photons. At absolute zero, there are no excited states, no motion, no energy to excite electrons. All atoms are in their ground state, the lowest possible energy level, and they stay there forever. The substance would not glow, would not radiate, would not emit anything. It would simply absorb light that hits it from outside and reflect whatever its surface properties allow. Passive, inert, dark unless illuminated from an external source. A perfect absorber that gives nothing back. And if consciousness could exist at absolute zero, which it absolutely cannot because consciousness requires biological processes, which require chemistry, which requires molecular motion, which requires temperatures incomprehensibly far above zero. But if it could somehow, if we imagine it as a thought experiment, time would feel irrelevant, meaningless. There would be no change to mark the passage of time, no internal processes progressing, no thoughts moving from one to the next because neurons are not firing, no neural activity because ions are not moving across membranes, no perception because sensory systems are not functioning. Just a frozen moment stretched into infinity, a single instant that never ends because there is no mechanism for the next instant to begin. Stasis, permanence, eternity. A consciousness frozen in a single thought forever. Unable to think the next thought. Unable to change or move or progress or end. Just existing in one frozen moment, forever. This is what the universe is approaching. Not quickly, not tomorrow or next year or next millennium, but inevitably, over timescales so vast they make human history look like an eye blink. The universe is expanding, cooling. The Big Bang was hot, incredibly hot, temperatures beyond comprehension, trillions of degrees, energy so dense that matter could not exist, only plasma, only radiation. But from that moment of maximum heat, the universe has been cooling, continuously, relentlessly. As space expands, the energy within it spreads thinner, dilutes, dissipates, the density drops, the temperature drops. After 380,000 years, it had cooled enough for atoms to form. After millions of years, enough for stars to ignite. After billions of years to the current state. 2.7 Kelvin, the cosmic microwave background, the afterglow of creation, still warm compared to absolute zero, but getting colder, and it continues to cool. Every year that passes, every century, every million years, every billion years, the cosmic microwave background gets a little colder, a tiny amount, imperceptible on human timescales, but measurable over cosmic time. Currently 2.7 Kelvin, eventually a trillion years from now, will be colder. 1 Kelvin perhaps, or 0.5. After 100 trillion years, after all the stars have burned out and died, after the last red dwarfs have exhausted their fuel and faded to black dwarfs, after even the white dwarfs have cooled to black dwarfs, after every possible stellar process has concluded, the temperature will be lower still. 0.1 Kelvin, 0.01, approaching zero, asymptotically, forever. And after the black holes have evaporated, after even the largest supermassive black holes at the centers of galaxies have finally radiated away through Hawking radiation over timescales of 10 to the 100 years, after protons themselves may have decayed, if proton decay is real, after every possible process that can release energy has finished, the universe will be dark, empty, and cold, approaching absolute zero, forever. Never quite reaching it because quantum mechanics and the third law prevent it, but close enough that the difference becomes philosophical rather than physical. For all practical purposes, the universe will be at absolute zero, frozen, still, silent, dead. This is not heat death exactly. Heat death is the state where entropy has reached its maximum, where all energy is evenly distributed throughout the universe at the same temperature, and no work can be done because there are no temperature gradients, no energy flow. That state is also incredibly cold, but it is distinct. the universe will reach a state of maximum entropy, and that state will be at a temperature asymptotically approaching absolute zero. The two concepts merge. The final state is both maximum entropy and minimum temperature. The universe cold and disordered. Energy spread so thin it might as well not exist. Structure dissolved. Complexity erased. Just space. Empty space. Cold space. Expanding forever. Cooling forever. Approaching but never reaching the ultimate limit. And nothing will ever change again. No stars will form because there is no gas left to collapse. No black holes will form because there is no matter to accrete. No light will travel because there are no sources, just darkness, cold, silence, forever. And what exists in that final state? What is there? Space exists. Empty space, still expanding, still growing, but empty, containing nothing, or almost nothing. Perhaps some photons, stretched to infinite wavelength by expansion, zero energy, perhaps some particles, electrons, positrons, neutrinos, scattered across distances so vast they might as well not exist. Each particle alone, isolated, trillions of light years from any other particle, drifting forever, but not moving in any meaningful sense because there is no reference frame, no other object to move relative to, just existing, in the cold, in the dark, in the silence, at a temperature so close to absolute zero that motion has nearly ceased, and that state persists, forever, not changing, unable to change, because there is no energy left to drive change, no process that can occur, no reactions, no decay, nothing, just existence, cold existence, empty existence, meaningless existence, the final state of everything. The screen fades to black, slowly, not a sudden cut, a gradual fade over 10 seconds, from gray to black, from something to nothing, complete black, deep black, the deepest black the screen can display, and silence. No music, no ambient sound, no narration, nothing, just black and silence for one full minute, 60 seconds of nothing. Letting the viewer sit with what they just heard, letting the implications sink in, letting the reality settle. The cold is real, the void is real. Absolute zero is real. The universe is dying, has been dying since it was born, cooling, expanding, fading. And eventually, after more time than can be comprehended, it will be cold. Colder than anything, colder than we can imagine. Approaching absolute zero, forever. The cold is waiting. It has always been waiting, and it will still be waiting long after everything else is gone. Long after stars, long after galaxies, long after matter itself, just cold and darkness and silence. The video ends, no credits, no music, no message, just emptiness.